So in this lecture, we are going to discuss regarding some matrix representation of a graph, as well as some of the vectors, vector space associated to a graph. So let us consider this graph with 4 vertices and 5 edges. So this is E1, E2, E3, E4 and E5. Now this graph G has 2 sets, or it is order pair with V and E, where V is consisting of 4 vertices. Let me say it is V1, V2, V3 and V4. So that's represented in this manner. And the 5 edges which we have, it is E1, E2, E3, E4 and E5. Now any subgraph H of G can be represented as 5 tuples. So any subgraph of H, any subgraph H of G can be represented by 5 tuples. Okay. So in that, the first one X, it is X1, X2, X3, X4 and X5. So this 5 tuple in such a way that this Xi value is either it is 0 or 1. It is 1 if EI is in H. If it is 0 if EI is not in H. For example, the graph or subgraph H1 let's say that subgraph H1 is this. So this is according, so it is a subgraph of this graph where I have plotted only E1, E3 and E5. So this is E1, E3 and E5. So how you represent this H1 will be represented by the 5 tuples. So in such a manner, this EI, it is in H. That means X1, the first vertex E1 is there in H. This is my H1 graph. So that is 1. E2, that is X2. E2 is not in H, so that is 0. E3 is exists in H, so that is again 1. E4 is not, and E5 is there. So this H1 can be represented in this 5 tuple. So how many possibilities are there? Such possibilities of this 5 tuple. How many possibilities are there of this 5 tuple?
25, I guess.
Why 25? The vertices remain same, just only combinations of edges you need to consider. So in the first place, how many entries should be exist at the, so you just see this. You have 5 places. The first place, second place, third place, fourth place, and fifth place. So in the first place, how many entries should be there?
5C3.
No. What I'm asking you, what is the entry should be in the first place? Only 2 entries is there, either 0 or 2, or sorry, 0 or 1. So that is only 2 digits will be appear here. So the possibilities of this entry is 2. Similar kind, a possibility of this entry is also 2. For this is also 2. For this one is also 2. For this one is also. Total possibilities are
10.
huh?
2. 2.
2 raised to 5.
2 raised to 5.
2 raised to 5.
So all is multiplication. Okay, all of them. The total possibilities will be 2 raised to 5. So there are 2 raised to 5 is equal to 32. Such 5 tuples possible, including 0 vector. That is 0 bar. Okay, that is 0, 0, 0. What does that mean of a 0, 0, 0? That means only the graph of this one is only there are 4 vertices, no edges will be there. And with the representation of null graph, this is a null graph is there. And what will be the 1, 1, 1, 1? What will be the graph 1, 1, 1, 1?
Identity graph.
1, 1, 1, 1, 1. What is this? Which is G itself, because we have started with the G. This is the graph G. And if you have all the vertices are there, so that is 1, 1, 1, 1. That is the graph G is there. Now, have you learned a vector space in your previous semester in linear algebra course?
Yes, sir.
Okay, so to define a vector space, or you required some operation to be defined. Okay, for example, if you want to say that R is a vector space, then R plus is the operation with that, and some scalar multiplication is also needed. Using this two, you can say that it is vector space. So likewise, we need to define here some operation. Okay, on the, so what we have started with the G, and there are subgraph of G. We have represented with the 5 tuples. So we are talking about this graph only, no other graph. If you have different graph, then you will have different type of vector space will be generated. So here for this, how many subgraph is possible for this graph? It is 2 raised to 5. 2 raised to 5 subgraphs are possible here. The ring sum operation between 2 subgraph. Now what we are doing is we are finding an operation between two. So there is a one graph H1 and another graph H2. If I want to do the sum of these two graphs, H1 plus H2, let us take the same example so you will understand. Let's say H1 is this. H1 I have considered the previously, it was this. This is my H1. So it is E1, E3 and E5. And this is my H1 graph. And I'm considering H2. H2 is this. So this is E2, E3 and E4. This is H2. So what is so this H1 contains E1, E3 and E5. So it's represented by, as we have already talked that, it will be represented by 1, E2 is not there, so it is 0, E3 is there, E4 is not there, and E5 is there. And H2 is equal to E2, E3, E4 is also represented by how E1 is not there, so it is 0, E2 is there, E3 is there, E4 is there, and E5 is not there. So H2 is represented by this. Now we need to do the sum of these two. So we are able to find out the sum of, so I need to do this direct sum of H1 plus H2. So what is the H1 plus H2? As our definition of addition or addition of a two graph or union of a two graph, it's E1, E2, E3 is in both. So that should not become E4 and E5. And how we got this? By just doing the addition of these two vectors. So might be you have learned a vector addition in your linear algebra course. So it is 1 plus 0 will gives me 1. 0 plus 1 will gives me 1. 1 plus 1 will gives me 2. And here the entry is only possible either 0 or 1. So what we are doing is we are applying the modulo 2 function. We already talked what do you mean by modulo 2 function. Modulo function, I think so in previous semester we have talked a lot. So whenever you have a number, some number, you divide that number by 2, whatever the remainder is there, that is your modulo. So here 1 plus 1 is 2. When you divide 2 by 2, it will give me 0. 0 plus 1 is 1 and 1 plus 0 is 1. So that means the E1 is there, E2 is there, E4 is there, E5 is there. So addition of these two is represented by this. Okay, which is a modulo function. Okay, and addition of 5 tuples in this manner it will be defined. So in this way we can able to define a vector addition. I can say a vector addition between two subgraph of the given graph G. And this modulo 2 is actually denoted as Galois field of 2. This is what a Galois field. Galois modulo 2. Okay, so how? So here we have I have given you one example. This graph G has four vertices, and with that we can construct a two subgraph of that, and we are trying to, or we have make the addition of these two subgraphs. In particular, if you have given any graph G with E number of vertices, sorry, no, number of edges. Then how many possible subgraph of the graph G is there? With same number of vertices will be there. Vertices will not be changed. Vertices will remain same. That means how many number of vectors you will have?
2 to the power e.
2 power e. The 2 power e vectors of e tuples is there. Okay, and with that we can able to define one vector x, which is x1, x2 up to xn. Another vector y, which is y1, y2 up to yn. Y I should write e because there are number of edges are e we have considered. Now what is this x1, x2 up to xe? They are either 0 or 1. Similarly for y also. In this space we consider what are the space of consisting of this many vectors. We define a vector sum that is x plus y in the manner x1 plus y1, x2 plus y2 up to xe plus ye with the function modulo 2. The modulo 2 is a function. Okay. Next, we'll need to define a scalar multiplication. Scalar multiplication a scalar C or between scalar C. This scalar C is in GF2. GF2 means it is either 0 or 1. So GF2 is exactly 0 or 1. This is GF2. And the vector x is x1, x2 up to xe. In this space, that means whatever the space of 2 power e vectors in that, will define like this, defined as c into x will be c x1, c x2 up to c xn, xe. This is also with the modulo 2 function. So this with modulo 2, this is we need to represent. Okay, in this manner, this will represent a vector space with these two operations. With these two operations, the graph G will be a vector space. In the space, so we can start with any graph, and in that graph we can construct a vector space, and then you can talk about lots of things whenever you require some linear algebra to deal with it. Okay, so that is just slightly flavor of how we can define a vector space into a graph. The next is the incidence matrix. So how to define incidence matrix? So let G be a graph with n vertices and e number of edges and no self loop. We define a matrix A equal to Aij of order n cross E. That means number of edges which are n, vertices will be n, number of edges is E, where n row correspond to the n vertices and E columns correspond to E edges. Now, how we define this Aij? As follows. This Aij is either 0 or 1. That is, Aij is defined is either 1 or 0. If it is 1, if this jth edge Ej is incident with incident on the ith vertex Vi, and this matrix A it's called incident matrix of G, and sometimes it's denoted by Ag. This is the notation. Ag. So let us have one example. Let's say this is V1, V2, V3, V4, V5, and here it is V6. So this is the graph with vertices V1, V2, V3, V4, V5, this is V6, and this one is V7. The edges denoted as E1, E2, E3, E4, E5, E6, E7, and E8. Now we'll to write down what is AG of this. So first of all, this is of order n cross E. N is number of vertices. That means number of rows are vertices. So let's say it is E1, sorry, V1, V2, V3, V4, V5, V6, and V7. These are the number of vertices. And the edges will be E1, E2. Columns will be edges. E2, E3, E4, E5, E6, E7, and E8. So this will be the graph, also the matrix you will have. Okay. Now, as per this definition, that means it is entry is 1 if the jth edge, that is Ej, is incident on the ith vertex Vi. That means this is the first edge is incident on V1. So that's my, it will be 1 here. Then E2, E2 is here, which is not incident with V1. So that's why 0. E3 is not incident with V1. So that's why it is 0. So all the other entry will become 0 because E1 is incident only with V1 and V2. So that's why it is 1 here. You can write, if you want, you can write 0 in all other places. For E2, E2 is incident with V2 and V3. So here 1 and here 1, and all other entry will become 0. E3 is incident with V3 and V6. So here it is 1 and here it is 1. All other entry will become 0. E4 is incident with V3 and V4. So here you have 1 and V4 you have 1. All other entry will become 0. E5. E5 is for this one. So it is V2, V4. So here it is 1 and all other entry will become 0. E6 is V4, V5. V4 is 1 and V5 is 1 and all other entry will be 0. E7, 6 and 7. So here it is 1, here it is 1 and all other entry will be 0. E8, 6, 7. So here it is 1, here it is also 1, all other entry will be 0. So this is your incident matrix with 7 by 8 matrix is there. Conversely, that means here there is a graph is given and we have obtained it, the incident matrix. When we have a matrix, that means if AG is this, if I given the AG in this manner, that is 0, 1, 1, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 1, 0, triple 0, 1, 1, 1, 0, 1, triple 0. Can we write or can we draw a matrix using this? So if I can denote, this is E1, E2, E3, E4, E5, and this one is V1, V2, V3, V4, and V5. Now E1 is connect with V2 and V3. So that means we have to start with this. This is E1, V2, and V3. E2 is connect with V1 and V4. So that is another vertex, that is E2 with connect with V1 and V4. E3 is connect to V2 and V4. V2 is here, V4 is here. So that means these two vertices are connected and that is E3. E4 is connect to V4 and V5. V5 is not here, so that's we need to draw again. So this is E4. E5 is connect to V1 and V3. So V1 and V3 is connected like this. This is E5. So this is the graph of corresponding graph, or if you plot in different manner, then it is isomorphic to this graph. Okay, so this is the incidence matrix. So what are the properties of incident matrix you have observed here? Can somebody tell me some properties of incident matrix? First, you should note that every column has how many? One,
2.
two. So each column of A of G has exactly two ones. Okay, since why this is, because every edge is incident with exactly two vertices. So that is the reason that every column has exactly two ones. A number of ones exist in the matrix. How many number of one is exist in the matrix? Can you say something regarding this? Or in in a column, we have talked about number of ones are there which represent exactly two. What about row? How many number of rows contains one? Or number of one in the row will represent something. For example, in the first row there are two one. So what will that represent? This two represent the one is here. It will represent the degree of that vertex. For example, in 4 there are three one. So that represent the degree of the vertex V4. Okay, so in general, the one, the number one of ones in each row equal to the degree of the corresponding vertex. So it will be the degree of the corresponding vertex. If some row contains 0, then what will be that represent? A row with all 0. What will be that vertex represent? That represent isolated vertex. What will that represent? The parallel edges. Suppose there is one of the parallel edges also there. Then what will be that represent? Suppose, for example, I have one extra edge E6, which is 1 0 1 0 0. Then E6 is this, E5 1 and 3, 1 and 3. So that is E6. Then what will happen? So in the incident matrix, two rows, see, two columns are identical. What does it mean? That means there is parallel edges. Okay, parallel edges in a graph produce identical columns. Now the next one is the incident matrix of connected graph. Connected diagram. What does it mean of a diagram? Diagraph means directed graph. So if you have a directed graph, then your matrix A equal to Aij have the number of rows is number of vertices, number of columns is edges. But this Aij in this case will be have three entry. 1, -1 and 0. 1 if the jth edge is incident out of ith vertex. This is jth edge is incident into the ith vertex. So this is otherwise neither incident out nor incident in. So let us have the example and we'll understand this. So for example, this is the graph. And the edges is the directed edges. And we need to denote the vertices. So this is V1, V2, V3, V4. And we have to denote the edges also. Let's say this is E1, E2, E3, E4, E5, E6, E7, and E8. Now what is AG? So there are four vertices, 1, 2, 3, and 4. And edges are 1, E2, E3, E4, 5, 6, 7, and 8. There are 8 edges. Now V1 is here. As per this, jth edge is incident out with the ith vertex, then it is 1. Jth is incident in, then it is -1, otherwise 0. So here is the 1. So we'll write first for column. So first E1 is incident into, this is incident into incident into V1 and out is, this is incident out, this is incident in. So for V1, what is the situation you will have in the first column? Tell me. This is the edge and the arrow is in this manner. So it is going inside V1. So what will be this entry according to this?
-1.
No, incident in to the ith vertex
1.
is -1.
Positive.
So what is jth edge? The jth edge is E1. So first edge is going inside to V1 and outward is 2v2. So if for inside, for into vertex, it is -1, and to outward vertex, it is 1. So where you will have 1 and where you have -1. Here you will have -1, and for V2 you will have 1. It is going out, and where it is going inside V1, and all other entry will be 0 for V2. So V2 is here. So is no, it is not uh, arrow is given here. No arrow is there. So that's why it is 0, 1, 1, 0. E3 is going into V3 and out for V4. So in it is -1, and for out it is 1. So that's why this is good. Out for V1, so it is 1. That will give me 0. For V5, for going in is V1, that will be -1. Out for V3, all entries. For V6, it is 1 for V2, -1 for V4. 1 for V7, for E7, 1 for V3, out for V4. So 1, 0, 0, 1, minus. For V4, V1. So for V1 it is -1 because going in, and for out it is V4. So this is the a matrix you will have. There is a very important result one can here write. We will not discussing the proof that if AG is an incident matrix, with n vertices, it has the rank is n-1. Okay, so the rank of the matrix will be n-1. We will not discuss in the proof of this one. Yes, lecture is there.
Yes, sir.
Yes, sir.
Yes,
No
sir.
one is
Yes,
replying.
sir. Yes, sir.
So adjacency matrix we'll discuss in the next lecture.